Previous lecture, we completed Oswald dilution law and then two terms, pH and pH, expression from which definition of pH and pH is made are given here. Today, we have to cover the points relation between pH and pH, types of solution or nature of the solution, pH scale and hydrolysis of salt. A relation between pH and pH. Question will be always asked for 2 marks. Give relation between pH and pH or show that pH plus pOH is equal to 40. Simple relation is here. We have seen Kw. We call it ionic product of water. Its expression is given concentration of H3O plus into concentration of OH minus ions. In this expression, here H3O plus ions, they are nothing but H plus ions. Why? H2 in water produces H plus OH minus ion. These H plus ions immediately with H2O molecule forms H3O plus ions. So H plus ions are nothing but H3O plus ions. The value of ionic product of water, that is Kw, we know 1 into 10 raised to minus 14 at 298 kV. The expression becomes concentration of H3O plus into concentration of OH minus. The value of ionic product of water is written here 1 into 10 raised to minus 14. Taking log on both sides, the equation becomes log of H2O plus log of OH minus I. Here is the product. When we take log, it becomes sum. Equal to log 1 into 10 raised to minus 14. Again, log of H2O plus log of OH minus I equal to log of 1 plus log of 10 raised to minus 40. Log of 1, characteristic 0, maintenance size 0. So log of 1 is always 0. Log of 10 raised to minus 14, we have written here minus 14 into log of 10. Again, this equation becomes equal to minus 14 into log of 10, characteristic 1, maintenance are 0. Then log of H3O plus log of OH minus I equal to minus 14 into this one, that is minus 14. Then changing the signs on both sides of the equation, this becomes negative plus this also becomes negative and this becomes positive. Written here minus log of H3O plus minus log of OH minus equal to 40. But we know minus log of H3O plus is nothing but pH, so written here pH, minus log of OH minus ion is equal to pOH, written here pOH equal to 40. So equation becomes pH plus pOH is equal to 40. Then what are the natures of the solutions? See here, when concentration of H3O plus and concentration of OH minus ion, they are equal, then such solutions are neutral solutions. Pure water is also neutral because concentration of H plus and concentration of OH minus ion is always equal. The value of concentration of H3O plus or value of concentration of OH minus ion in case of neutral solution or pure water, it is already known. It is 1 into 10 raised to minus 7. This concentration is 1 into 10 raised to minus 7. This concentration is again equal to 1 into 10 raised to minus 7. Both are equal. Such solutions are neutral in medium. So, in case of neutral solution, What is the value of pH? If we know the concentration of H3O plus ion, that is 1 into 10 raised to minus 7. If we put this value in this expression, and we can determine its pH as like this. Here, definition of pH is negative log concentration of H3O plus. Putting the value of concentration of H3O plus as 1 into 10 raised to minus 7 in this expression. Then, solving this equal to minus sign here into bracket minus 7 into log of 10 minus 7 into log of 10. Log of 10 is always 1. So equal to minus in bracket minus 7 into 1. Equation again becomes minus 7 into bracket minus 7 into 1 minus 7 minus minus here becomes equal to plus. So pH equal to 7. Then you can remember here, in case of pure water or in case of any aqueous neutral solution where the concentration of H3O plus or concentration of OH minus ions are equal to 1 into 10 raised to minus 7, then for that solution pH is always equal to 7. So remember, for neutral solution pH is equal to 7. What is in case of acidic solution? In case of acidic solution, this concentration is not equal like this. If solution is acid, then concentration of pH plus ions or H2O plus ions, they are always greater than OH minus ions. Means we can in another way say that concentration of H3O plus is always greater than 1 into 10 raised to minus 7. For example, we can say that concentration of H3O plus is greater than this quantity, means it may be 1 into 10 raised to minus 6, it may be 1 into 10 raised to minus 7, 6, 5 or 4 or 3, it may be. Concentration of H2O plus is greater than 1 into 10 raised to minus 7, means if we take the concentration of H2O plus greater than 1 into 10 raised to minus 7, in that if we take 1 into 10 raised to minus 6, then pH of that solution becomes equal to 6. Means concentration of H3O plus when it is greater than 1 into 10 raised to minus 7, then for such solution pH is always less than 7. It may be 6, 5, 4. So we have to remember here, for acidic solution pH is always less than 7. In case of basic solution, again these concentrations are not equal. In case of basic solution, this concentration of H plus H3O plus is always less than concentration of OH ion. This concentration is greater than this. That is, concentration of H3O plus is always less than 1 into 10 raised to minus 7. Means you can say that concentration of H3O plus, it may be less than this quantity, means 1 into 10 raised to maybe minus 8, minus 9, minus 10 as it is. Hence for such solution pH becomes always greater than 7. pH values means pH becomes 8, 9, 10, 11 as like this. So you have to remember, for neutral solution pH is always 7 and concentration of both these ions are equal. In case of acidic solution, concentration of H3O plus is greater than concentration of OH minus. For such solution pH is less than 7. In case of basic solution, concentration of H3O plus is less than concentration of OH minus ion. For such solutions pH becomes greater than 7. You have to remember all these three values of concentrations and pH. To determine the nature of solution, whether it is acidic, basic or neutral, Sorensen, the scientist Sorensen, has given a scale called pH scale. Observe here this pH scale. Here two values are given. Below values are concentration of H3O plus, that is 1, 10 raised to minus 1 up to 10 raised to minus 40. From this concentration of H3O plus, pH are determined and they are given here from 0 to 40. Always remember, pH scale always starts from the pH value 0 and ends up to pH 40. So pH of the solution lies in between 0 to 40. In this scale, we have written here the middle points here. Concentration of H3O plus is 10 raised to minus 7. For that solution, we have determined pH. Concentration of H2O plus given 1 into 10 raised to minus 7, pH comes here 7. So pH is given here 7. Such solution are neutral in nature. These are neutral solutions. Solutions whose concentration of H2O plus is 10 raised to minus 7 or whose pH is equal to 7 are neutral in medium. See here, in case of acidic solution, the concentration of H2O plus, it ranges from 1 up to 10 raised to minus 7. This range from 1 to 10 raised to minus 7. pH values comes here from 0 to 7. Here we have seen that in case of acidic solution, pH is always less than 7. So pH is less than 7, that is 6, 5, 4, 3. These solutions from pH 0 to 7 are acidic in nature. Remember here. Here, when pH increases from 8 to 40 or concentration values are less than 1 into 10 raised to minus 7, that is 10 raised to minus 8 up to 10 raised to minus 40, pH values comes here 8 to 40. That is, the pH values increases from 7 to 40. So from this 7 to 40, the nature of the solution is basic. Here we have seen that for basic solution pH is always greater than 7. See here, it is greater than 7. This range indicates the nature of the solution basic. So this pH range is important to know what is the nature of solution, whether it is neutral, acidic or the basic. Then what is hydrolysis? Hydrolysis of salt. Generally we know that when acid combines with base, it forms salt and water. This reaction is called neutralization. Why it is neutralization? Because salt is neutral in nature, water is neutral. Neutral solution is formed from acid and base, so called neutralization. A reverse of this reaction, that is, when salt combines with water forming acid and base, this reaction is called hydrolysis. Remember this meaning of neutralization and hydrolysis. Based on this, types of salts are given. This salt when reacts with water forms acid and base. Here, it is not important to remember the definition of neutralization, but you have to remember the general definition of hydrolysis, that is salt plus water forms acid and base. When the salt reacts with water forms acid and base, based upon the nature of acid and base form, based upon the nature of acid and base form in hydrolysis reaction, the salts are classified into these four types. कैसे अपन क्लासिफिकेशन केलं आहे? हा सॉल्ट जेव्हा पाण्याबरोबर रिॲक्ट होईल आणि ऍसिड आणि बेस तयार करेल तेव्हा तयार केलेल्या ऍसिड आणि बेसचं नेचर काय आहे याच्यावरून या सॉल्टचे प्रकार आपल्याला 4 सांगता येतात. आता हे 4 प्रकार आपल्याला लक्षात ठेवण्यासाठी आपल्याला काही उदाहरणं वीक ऍसिड कोणता आहे, वीक बेस कोणता आहे, स्ट्रॉंग ऍसिड कोणता, स्ट्रॉंग बेस कोणता याची काही उदाहरणं आपल्याला पहिल्यांदा माहीत असणं गरजेचं आहे. म्हणजे आपल्याला हे सॉल्टचे प्रकार इझिली लक्षात ठेवता येतील. वीक ऍसिड्स कुठले आहेत? वीक ऍसिड्स ऍसिटिक ऍसिड, फॉर्मिक ऍसिड आहे, कार्बोनिक ऍसिड आहे, हायड्रोसायनिक ऍसिड आहे HCl, यांना आपण वीक ऍसिड म्हणतो. वीक बेसेस NH4OH, CuOH ट्वाइस यासारखे वीक बेसेस आहेत. स्ट्रॉंग ऍसिड्स HCl, HNO3, H2SO4 त्यांना स्ट्रॉंग ऍसिड्स म्हणतो. स्ट्रॉंग बेसेस NaOH, KOH यांना आपण स्ट्रॉंग बेसेस असतो. तर याच्यामध्ये आपण पहिला प्रकार घेतला टाइप्स ऑफ सॉल्ट्स. पहिला प्रकार दिसतोय आपल्याला सॉल्ट्स डिराइव्ड फ्रॉम स्ट्रॉंग ऍसिड अँड स्ट्रॉंग बेस. जर हा सॉल्ट वॉटर बरोबर रिॲक्ट होऊन ऍसिड कसं तयार करेल? स्ट्रॉंग नेचर्स. आणि बेस कोणत्या नेचरचा तयार करेल? स्ट्रॉंग नेचर्स. असं जर होत असेल तर त्या सॉल्टला म्हणायचं सॉल्ट डिराइव्ड फ्रॉम स्ट्रॉंग ऍसिड अँड स्ट्रॉंग बेस. फॉर एक्झाम्पल गिवन हियर NaCl. हा NaCl सॉल्ट जेव्हा वॉटर बरोबर रिॲक्ट होईल त्यावेळी ऍसिड आणि बेस तयार होईल. त्यावेळी ऍसिड कोणतं तयार होईल? हा NaCl सॉल्ट पाण्याबरोबर रिॲक्ट झाला तर याच्यापासून ऍसिड तयार होईल HCl. पाण्यातला H Cl बरोबर कंबाईन होईल HCl ऍसिड तयार होईल. पाण्यातला OH Na बरोबर कंबाईन होईल आणि OH तयार होईल. म्हणजे इथे HCl आणि NaOH तयार होईल. जर नेचर बघितलं HClचं आणि NaOHचं तर दोन्हीही काय HCl स्ट्रॉंग ऍसिड आहे, NaOH स्ट्रॉंग बेस आहे. म्हणून या प्रकारचा सॉल्ट हा कोणत्या प्रकारात येतो? या प्रकारात येतो. अशीच आपण काही उदाहरणं दिलेली आहेत. NaCl, KCl, Na2SO4, NaNO3, KNO3. हे सॉल्ट्स पाण्याबरोबर कुठले कुठले ऍसिड्स आणि बेसेस तयार करतील याचा आपण घरी विचार करायचा आहे. आणि तो सॉल्ट याच प्रकारातला काय हे आपल्याला म्हणता येते करायचं. बाकीच्या 3 प्रकारच्या सॉल्टचं नेचर किंवा त्याची उदाहरणं आपण नेक्स्ट लेक्चरला पाहणार आहोत. आपण इथंच थांबूया. थँक्यू.